Now that we know how to solve a system of two equations, we want to look at how do we solve a system with three equations. Now, in this course, this is where we'll max out. We want three variables and three equations. Yes, are there other ways or other systems to solve? Yes, we could have four equations. We could have five equations. We could have however many equations with however many variables, but that's for another course, okay? So this is going to be a mixture of the two type of ways that we looked at when we were solving a system with two equations. Remember, those two methods we looked at were substitution and elimination. So when we have three variables, okay, this time it's not only an x and a y, but it's an x, y, z. So if you've ever thought in 3-dimension, right, or looked at graphing that kind of way, that's what this will look like. So I still have the same ways of how we'll have solutions, right? I still have exactly one solution, which this would be in a 3D type of graph. It would be an x, y, z axis, which we will not graph that, right? So the only way that we are going to be able to solve these, we're not going to be looking at a graph. Instead, we're going to be looking at equations. So when we look at an equation, I can still get the same thing where I either get an answer, I get no solution, or I get infinite solutions, okay? If that happens, I'm still going to look for, do I have a true statement or do I have a false statement? A true statement would be infinite, a false statement would be no solution. And again, it's when all the variables cancel off, okay? Now, what we mainly want to look at is what happens when we have exactly one solution, when I can solve for all three of these variables, okay? So it's going to look like a combination of the two methods. We're going to start off with that elimination method, but I mean, we could have also called it addition, right? I'm going to start off with that. Then I'm going to break that down into now two equations. So now I have the option to solve with substitution or elimination. Then at the very end, I'm going to go back and I'm going to substitute. So I'll see both of those methods present in this process, okay? Now, because I'm using the same methods, it's not any more difficult than solving with two variables. However, it is more lengthy, right? Because what I have to do first is narrow three equations down to just two equations. Then I have to do the whole two equation process. So I'm adding on an extra 2 steps to what we had been doing. So it's a little bit longer, but it's not too bad. Okay, so let's look at an example so we can kind of work through this and see what's happening. So let's look at this first example. So we want to start off with elimination method. So remember, with our elimination method, we want to pick a variable to be able to eliminate. So when I'm looking at the variables, I want to be able to look at all three of the equations and determine how they might cancel off, okay? Now, some of these equations, it might end up being that the x and the y are just as easy to eliminate, or maybe the y and the z. So there's going to be lots of different options, and it's just up to you to determine whatever you want to do. So let's look at these equations here. So if I look at the x variable, the 4, and the -3. So the two 4s, that'd be easy to cancel. And a 4 and a 3, they'd have to multiply to equal 12. All right, let's look at my next variable. So I look at, well, the y by itself, that would be easy because I can multiply it by 3 or 4 and they'd easily cancel. And then I'd have my last variable, my 4 and my 4, those would already cancel because one's positive and one's negative. And then my 2 and my 4, I just need to multiply by 2. So I'm going to go ahead and pick, and remember, it's up to you. I'm going to go ahead and pick my z variable, okay? So I'm going to pick z. And the reason that I am picking z is because that when I put equations 1 and equations 3 together, they're going to cancel. So the first thing that I'm going to do is I'm going to put equation, just abbreviate, 1, and equation 3 together. That will quickly be able to cancel because I already have a positive 4 and a negative 4. Then the next thing that I'm going to do, my next combination, is I'm going to pick, let's say, equation 1 and equation 2. Because I already have a positive and a negative, I just need to multiply by 2. So I'm going to pick equation 1 and equation 2. So that's what I mean by we're going to eliminate the variable using 2 different combinations of 2 equations. So now that I've picked those combinations, I'm going to actually do what I said. So let's start off with our first one. We are picking equation 1 and equation 3. So let's say we have equation 1, which is 4x minus 4y plus 4z equals negative 4. And then equation 3, which is negative 3x minus 3y minus 4z equals negative 16. Now remember that we have picked z. We have to get rid of z. So looking at z, they are already ready, meaning that I already have the same number with opposite signs. So I'm going to go ahead and start adding these together. When I add these together, I'll get an x minus 7y. My z's will cancel, and I'll equal negative 20, right? So that one is done for the moment because I have eliminated z. That's all I was trying to do. Okay, so now let's look at our other combination. We have equation 1 again, so let's write that down. 4x minus 4y plus 4z equals negative 4. And then we have equation 2. 4x plus y minus 2z equals 5. All right, so remember I have to eliminate that z. So to do that, I'm going to have to multiply that entire equation by a 2. That way I'll have a positive 4z and a negative 4z. All right, so let's rewrite our first equation because I didn't do anything with it. So we have 4x minus 4y plus 4z equals negative 4. My second equation, I now have 8x plus 2y minus 4z equals 10. So now I'm ready to eliminate. I'm ready to add them together and cancel. So let's add those first two. I get a 12x. Adding my next two, I get a negative 2x. My z's cancel off, equal to 6. All right, so at this point, I now have completed that first step. Okay, I've narrowed it down to 2 equations with 2 variables. So I have my equation x minus 7y equals negative 20 and my equation 12x minus 2y equals 6. So now when I have these 2 equations together, I'm going to solve 2 equations just like we solved in our last section. So let's go ahead and write those equations down together so we can see them here. So I've got 12x minus 2y equals 6, and I have x minus 7y equals negative 20. So now it's up to you how you want to solve. Remember, I've got 2 options. One option is that substitution. And then my second option is elimination. It's up to you how you want to go about doing this. So for me, I'm going to go ahead and let's just eliminate. Since we're already kind of in the process of doing that one, let's just keep going. So I'm choosing to eliminate. You don't have to. It's up to you. So when I eliminate, I'm going to look at this. I'm going to multiply this bottom equation by a negative 12. Okay, that way I can cancel off my x's. So I'm going to leave that first equation the way it is. I'm going to multiply that next equation by a negative 12. Then what I'm going to do is I'm going to add them together, right? My elimination method says multiply by what I need and add to eliminate. So those x's are going to cancel. I'm going to end up with 82y equals 246. Then I'm going to divide by 82. So y should equal 3. So at this point, I have now found one of my variables. Okay? So after I find one variable, it's all about going back and substituting. So I'm going to take this y back into one of my two variable equations. Doesn't matter which one. Okay, so let's say that I decide I'm going to go back to my x minus 7. Instead of y, I'm going to use the number 3 now, equals negative 20. So I'm going to solve my equation. So I've got x minus 21 equals negative 20. Add that 21. So I'm going to get x equals 1. Now I'm going to take that 1 and I'm going to go back with my x equals 1 and my y equals 3. I'm going to go back to one of the original equations. Okay, so now I'm going to use my x equals 1 and my y equals 3. And we're going back to one of those very original equations. So one of my 3 original equations, and let's say that I'm going to pick, I don't know, let's go with equation 1, just because it's the first one there. So I'm going to go back to equation 1. All right, so I'm going to plug in. So I have 4 times now 1 minus 4 times now 3 plus 4z equals negative 4. All right, so I plug in my x and my y, and now let's go ahead and solve it. So I'm going to have 4 minus 12 plus 4z equals negative 4. So I'm going to have negative 8 plus 4z equals negative 4. I'm going to add that 8. So I'm going to have 4z equals 4. Then I'm going to divide by 4. So I get z to equal 1. So now that I've got my 3 answers, I've got a y, I've got an x, and I've got a z, I can write my ordered pair as x, which was 1, y, which was 3, and z, which was 1. Right? So I'm using a combination of elimination and substitution as we go through and we solve these. I take 3 equations down to 2 equations. I take 2 equations down to a single answer, and then I substitute, get my final answer. So again, not that it's more difficult, there's just lots of different kind of places to make a little error. So I have to be very careful, follow it all the way through, make sure that every time I do this, I'm checking my signs, I'm making sure I'm eliminating the correct variable, and just that I'm taking my time and watching out for little mistakes, right? But now I should be able to solve 3 variables with 3 equations.